Hello Flight Simmers and welcome back to Alpha Hotel Flight Simulator Training. This is lesson 2 in our Garmin 530 and 430 tutorial series. In this video we'll talk about using the Garmin 530 and 430 receivers for en route IFR operations. We'll talk about loading IFR departure and arrival procedures and then look at a sample IFR flight plan that incorporates using those. In the next video we'll talk about using these receivers for instrument approaches. As I mentioned in our last video, you can load a flight plan in the GPS in one of two ways, either manually entering it in the GPS or by creating it in the Flight Simulator Flight Planner, which will then automatically load it in the GPS when you click Fly. And as I mentioned last time, the most efficient way to load an IFR flight plan is a hybrid method, loading your en route portion via the flight planner, then loading any IFR departures or arrivals in the GPS once you've started the flight. The point-and-click interface on the flight planner is much quicker for entering each en route point on the en route portion of a flight plan than the twisting and turning you need to do to get each waypoint into the GPS. But loading IFR departures and arrivals in the flight planner is quirky at best, often giving you limited options to select routes and transitions. It sometimes cuts en route points off the flight plan you created when you try to load a procedure, and some procedures don't load correctly. Conversely, loading a departure or arrival directly into the GPS is pretty efficient and straightforward and gives you full access to all of the procedure's transition routes. So when you create a flight plan in the flight planner, it gives you a couple different options on how to do it. Of course, we do have to load our departure and arrival airports before we get those options. Once we do that, an option box will appear below the aircraft selection icon and let us know what we can do. Obviously, we've talked about the direct GPS, and we talked last time about the VOR to VOR option. We also have IFR options for low altitude airways and high altitude airways. The problem with the IFR option is that, like the VOR to VOR VFR option, this automatically creates a route for you, and the way that it does it is unpredictable. It's not always logical, and it's not always close to what you want to fly. So for this reason, I still tend to use the VFR direct option even when flying IFR, as it gives me a clean slate to build a route with. The problem with this is that it creates complications if you want to go through the motions of picking up an IFR clearance for realism. So let's talk about ways to work around that, as it is a little quirky. If you're departing a towered airport in Flight Sim and you've loaded an IFR procedure in your GPS, in other words, a departure or SID or arrival or STAR, you can still get an IFR clearance on your flight plan route, even if that flight plan was a VFR flight plan. If you don't have an IFR procedure in your GPS, you won't be able to get an IFR clearance on the ground from clearance delivery. You'll need to use one of the IFR flight planning functions, and we'll talk about that in a second. You also have the option of departing VFR and getting the IFR clearance in the air once you can contact departure control or center. You can do this if the weather is VFR, or you can select the option to ignore the weather if it's IFR. If you go this route, it doesn't matter what's loaded in the GPS. If you're departing from an uncontrolled field, you won't be able to pick up an IFR clearance on the ground if you filed a VFR flight plan, regardless of what's in the GPS. You have two options here as well. You can take off and get the clearance once you get airborne and can talk to the departure control or center. This will work regardless of what's loaded in the GPS. But if you'd prefer to get the clearance on the ground before you get airborne, you'll need to use one of the IFR flight planning options. If you want to do that, but still want to build your flight plan from scratch, you'll need to delete all the en route fixes that Flight Sim loads and then rebuild the flight plan the way you want to. Let's talk through how to do this. So I've got a flight plan here between Pine Bluff Airport in Arkansas and Addison Airport in Dallas, Texas. And this won't be one we'll actually fly on this particular lesson, but we'll use this as an example of how to clear out an IFR route. So I will select the low altitude airway option on the routing tab here. And it selects a route that goes over up to Hot Springs and then down, and I'd rather go down over Texarkana area. So what I do is go to each fix along the way here and just left click on that and then remove it and just go through all the fixes there and remove all of them. And once I do that, then we'll have a clean slate to work with, and it will be an IFR flight plan. So that's how we clear out an IFR flight plan and create a blank slate like that. Occasionally we do this, you will have a fix that you won't be able to delete. It'll show up on the fix list, but you won't actually be able to see it. See if I click on Ronnie here, it doesn't bring up the usual dialog box, and I can see where the turn is there, but if I zoom in on it, you can't see the fix at all, and so you can't delete it. So if that happens, just cycle back to the direct GPS route again, and then cycle back to the low altitude airways, and usually that will take care of it, and you can go through and see now Ronnie is showing up and I can take it out of there. Another quirk with flying IFR flight plans in the flight simulator is that not all IFR procedures are available in Flight Simulator. Some departures, arrivals, and approaches are just not in the database, so they can't be loaded in your GPS. The good news here is that even though these procedures are missing, the fixes that define them are usually still in Flight Sim, so we can actually build them in the flight planner, and we'll talk about doing that. This is not something you should ever do in the real world, but since there are so many missing procedures in Flight Simulator, this gives us a way to fly those. If you want to see if an airport that you're wanting to fly in or out of has a procedure, this is where that IFR flight plan option actually comes in handy. It's a good way to check the database before you actually load something up and try to fly it, or try to load it and try to fly it. So I've got a route here between Addison, Texas, and Bird's Nest or Austin Executive Airport down near Austin. And so I'm going to check and see there's some departures I want to fly in and out of both of these airports. So I'll take a look and see if they're there. So I'll select the IFR low altitude route, and you'll notice that brings up another tab over here for departures. And then with the arrival airport, it brings up arrivals and approaches. And so if I take a look at departures, I want to fly the Joe Pool departure out of Addison. So I take a look at the tab here, and the Joe Pool is in here. And I don't want to use the flight planner to load it up because, again, it doesn't give me a choice of transition, and it's going to load it up kind of funny. So I want to load that in the GPS, but by checking here, I know that that's in the database. I want to fly the blue arrival into Austin Executive, so I'll check here. And all I have is the Potter one and the Biter one, or the Bitter one, or the Bitter 9. So the blue arrival is not in here, so I know that I have to build that arrival. That's not going to be something I can load in the database. It's not in there. If you pull up an airport and the only thing it says in there is departures direct or arrivals direct, that means there are no departures or arrivals loaded for that particular airport. And the same goes for approaches. So if I pull down the approach tab here at Austin Executive, it doesn't have any approaches listed. It just says automatic. So this tells me that there are no approaches for this airport in the database, even though there are some approaches, some GPS approaches to this airport in real life. Another note on doing this is if you are going to edit a flight plan, make sure that you check to see if your departures and arrivals are in there first before you start editing, because if you're going from, say, a GPS direct mode to the IFR mode, and then you go back to the GPS mode, if you've edited a flight in any other mode but the mode you're currently in, then when you go back to the other mode, it will clear everything out and it will auto route again. So if you've created a nice route with your GPS direct option, and then you go to check it to see if your procedures are in there, and then you go back to GPS, it's going to clear all of that out. So make sure and check the IFR tab before you go about route editing. And one last quirk when you're loading a flight plan to fly IFR in Flight Simulator is that you generally don't want to load an approach in the flight planner or GPS when building your route. Doing this will often delete your last few en route fixes or the last few fixes on the arrival. So in general, it's best to wait until you've passed your last en route fix or arrival fix, and then select and activate your approach if you want to fly an approach. There is an exception to this rule. If your en route flight plan or the arrival you're flying contains a fix that's also on the approach, you can generally go ahead and load the approach, and we'll talk about some specific examples of this in some of our sample flight plans. But for the most part, when you're doing a flight plan, don't load an approach. just wait until you're ready to fly the approach to activate that approach. The biggest difference between VFR and IFR en route operations is using and loading standard instrument departures, or SIDs, and standard terminal arrival routes, or STARs, in the GPS. SIDs and STARs are typically used at large metro airports and their surrounding satellite airports, though there are some arrival and departure procedures at smaller airports as well. There are two different types of arrival and departure procedures available in the GPS database. Traditional SIDs and STARs that were designed based on using ground-based navigation aids, and RNAV procedures that use GPS waypoints to fly them. With the traditional arrivals, unlike approaches using ground-based nav aids, you don't have to use or even reference the ground-based nav aids when flying these procedures. You can fly them entirely on the GPS. Of course, for an RNAV procedure, the only way to fly them is using a GPS or FMS. You can tell whether a procedure is a traditional ground-based procedure or an RNAV procedure by looking at the title. If the procedure is an RNAV procedure, the procedure title will be followed by the word RNAV in parentheses. A traditional ground-based procedure will not have this. On SkyVector, this is also included in the list of procedures, so you can quickly see which ones are RNAV and which are not. First, let's look at standard instrument departures, or SIDs. There are basically four ways a SID will get you out of town. The first type gives you some sort of initial climb instructions, then says expect radar vectors to filed or assigned route. These are typically seen at Class C sized airports and airports close by. While you can load these in the GPS and flight simulator, they're not built correctly, often just putting a user fix a mile or so off the departure into the runway, usually not in the right place, then connecting that to your first en route fix. It's honestly better not to load these types of departures in the GPS and flight simulator. Just fly the climb procedure manually. It's usually just a turn at a certain altitude, then holding that heading to another altitude. After you've completed the initial climb procedure, turn towards and proceed direct to your first en route fix. So an example of this type of procedure would be the Razorback 3 departure out of Drake Field in Fayetteville, Arkansas. This is one of the sample flight plans that we'll look at as a flight from Drake Field in Fayetteville down to Addison, Texas. And it says in the route description down here, it says for takeoff on runway 16, which is what we're going to use, we need to do a climbing right turn to a heading of 180, then stay on that heading to 3,800 feet, and then expect radar vectors to our filed assigned route. And then it gives us climb instructions to climb up either to 5,000 or lower assigned altitude. So again, we're not going to put this in the GPS because it won't put anything we can really use. It won't have the turn to 180 in there, and it won't know when we get to 3,800 feet. So we'll just do all that manually, and we won't load that. And then once we get to 3,800 feet, we'll turn towards our first en route fix, and then we'll proceed direct to that fix in the GPS. The second type is a SID that gives you initial climb instructions and then tells you to expect vectors to join the departure route. The departure route may be a single route, or there may be multiple transitions to choose from with different endpoints depending on which way you're headed. And these can be traditional or RNAV routes. To fly this type of departure, you'll need to load the departure in the GPS to get the route. You'll also need to load a departure runway as part of this process. It will still load a user waypoint for the initial climb, and like the previous procedure, it won't load correctly. So you should just ignore it and fly the climb procedure manually. The user waypoint will connect with the first fix on the departure route, so once you've completed the initial climb procedure, you can steer yourself back on course and resume GPS navigation. So an example of this type of departure would be the Lakes 3 departure out of Kansas City Downtown Airport. One of the sample flights we'll do will be from Kansas City Downtown to Spirit of St. Louis Airport, and we're going to use this departure out of Kansas City Downtown. It has two pages. This is the first page, which shows us the route, and then the second page gives us the route description, and that's what has our initial climb procedure. We'll be using runway 19, so the climb procedure for that is going to be climbing right turn to heading 215 to 2,500 feet. Then it gives us the route that we follow, and it's got different routes depending on where you're going. we'll be using the Columbia transition. So you want to you do want to load this in the GPS because you need that to get the route, but you're going to ignore what's in the GPS for the initial climb, and then once you get 2,500 feet, then you can steer yourself on course or go direct to something that's on the departure route. The third type is a SID that has instructions to fly an ATC assigned heading and altitude for vectors to join the departure. This type of departure is not runway dependent, and when you load it in the GPS, it will build the route from your departure airport to the first departure fix, and then along your programmed departure route. Like the last procedure we mentioned, the departure may have multiple outbound transitions, and it may be traditional or RNAV. With this type of procedure, take off and climb to a safe altitude, usually on runway heading, then turn either direct to the first departure fix or set up to intercept the departure route or proceed direct to a downline departure fix. So an example of this type of departure would be the Joe Pool 2 departure out of Addison, Texas. Again, like the previous departure, it has 2 pages. The first page has the route information and shows you all the different transitions that you can take depending on which way you're going. And then the second page has the climb instructions and descriptions of the different routes and some notes. So the instructions just say when entering controlled airspace, fly assigned heading and altitude and expect vectors to the appropriate route. So usually what you'll do is take off and fly runway heading up to about 400 feet or so, and then start making a turn either to intercept the course or to go direct to like a down like fix. Like for instance, we'll be doing the Windu transition. So we might take off and then head kind of this direction and then go direct to Jaspa or intercept the route south of Maverick VOR. The final type of SID is a runway-dependent RNAV departure. These procedures are designed for aircraft to navigate on them right after liftoff and fly a specific path that is dependent on the runway you depart from. They're usually designed for turbojet aircraft flying out of busy commercial airports, though there are a few at mountainous airports as well. They often contain steep climb gradients not doable by GA aircraft, but the lateral portion of them works fine in Flight Simulator and can be loaded and flown in the Garmin units if you want to try them out. So an example of this type of departure would be the BB King 7 departure out of Memphis International and Memphis, Tennessee. You can see there are different routes that you will fly based on the runway that you're taking off of. For example, if you're taking off of 18 left, you'd fly a 180 heading to intercept a 163 course to Ribs, then Henier, then Wallace, and then Lilu, and enjoy the common departure after that. Or if you're going off a 36 right, you would fly a 360 heading to join a 032 course to Jax, and then Ayer, and then Stud, and then Lilu to join the common departure route. In fact, if you're taking off of 9 and 27, you just fly a heading and you get vectors to the expected route. If you have any doubt as to what you're supposed to do, the second page has a route description for each runway. So if you're taking off on 18 left, make sure you're doing what you're supposed to. You take a look and it says climb on a heading 180, intercept the course, the 163 course to Ribs, then follow that depicted route out to BB King intersection. At airports with a lot of runways, the departure routes can be quite diverse on a single departure. As you can see, this is looking at Atlanta Hartsfield-Jackson International Airport in Atlanta, Georgia. And what route you take depends on if you're taking off from the far south complex, the center complex, or the north complex, or whether you're going east or west. You can see if you're taking off west going north, there's one route that you fly. If you're taking off of the center complex headed to the west, then there's another route that you fly. And if you're taking off the far south complex, there's another route that you're going to fly. And the same thing holds true if you're going east. There's 3 different routes, actually 2 different routes. The north has its own, and then the center and south complex have their own basically routes. But there's a lot of different ways you can go on this one departure, just depending on which runway you're using. Now let's talk a little bit about standard terminal arrival routes, or STARS. Like SIDS, these can be designed as traditional ground-based procedures or as RNAV procedures, but flying them with the GPS works the same regardless of their design. There are basically two types, non-runway dependent and runway dependent. The ones that are not runway dependent may be a single course that terminates at a single endpoint, or it may have many transitions that funnel traffic down to a single point at the end of the arrival. It may instruct you to fly a heading after reaching the final fix, or it may tell you to expect vectors to your approach prior to reaching that fix. If the instruction is to fly a heading after the final fix, the GPS will have a user waypoint built into the arrival that is 5 miles from the last fix on that heading. Well, technically it's a track, but it will get you pointed in the right direction. It will then sequence from the user waypoint directly to your destination airport. When you get to this turn point and make that turn, this is your cue to fly a heading rather than following the GPS track, and either load or activate an approach in the GPS or maneuver for a visual landing or other instrument approach. With runway-dependent stars, the path you fly is dependent on the runway you plan to use. With these arrivals, they may terminate like non-runway dependent arrivals, or they may actually line you up with an approach to an arrival runway. For example, if we're flying the Glavin 1 arrival and we are landing runway 26 right or left, we fly over Glavin and then Southern and then Hog and then make a downwind route out to Kiwi and then take up a 095 track or heading after Kiwi for a left downwind, or excuse me, for a right downwind and vectors to the 26 approaches. If we are landing, say, 8 left, we fly over Glavin, then Southern, and then along this route down to JJ. And JJ is actually a fix on the approach for 8 left. If you have any doubt what you're supposed to fly on a runway-dependent arrival, there's a narrative that breaks down the route for each runway that you can check and see what you're supposed to do. You'll also notice with stars that for smaller airports in a metro area, a single star may serve multiple airports, and that the route that you fly may be dependent on where you're landing. So be sure to pay attention to the narrative or route description, which is sometimes found on a second or third page, to know what you're supposed to fly. One of the challenges in flying into large terminal areas IFR and using stars is figuring out which star and transition to use. What I usually do is load the direct route and then see what star and transition point is closest to that. Stars usually arrive in large terminal areas from the corners of those areas, so just browsing through the stars to see which direction they come from will usually tell you which one to pick. Often there is an RNAV star and a traditional star on the same basic routing, so in that case you'll have your choice of which one to use. Sometimes you'll also see two different stars coming in from the same direction, and if you look at the notes on that star, one will be for turbojets only and one will be for non-turbojets, and usually there's a note on the turbojet star as to which star you should use if you're not flying a turbojet. So check the notes carefully and make sure that you are using a star that is available to your type of aircraft. With most traditional stars, the start points for many transitions are VORs, so they're easy to see on en route charts and figure out which one is closest to you and get some hints as to where the start points that are not nav aids are. You can also route yourself on an airway to a start point. For RNAV arrivals, the start points are GPS waypoints, so you may have to use a search function on your planner to figure out where they are, what they're close to, and what points you should use. Another technique is to use a flight following site like FlightAware. Enter the two airports you'd like to fly between and see if anyone's flown that IFR lately and what route they used. You can also search the Preferred Routes database query at the Air Traffic Control System Command Center's website to see if there's a route preferred by ATC in the real world. Just enter the departure and destination 3-letter FAA codes and whether you want to fly low or high altitude, and it will return a preferred route if there is one. These usually only exist for the largest airports in large terminal areas, but if you're planning a flight between big airports, you can pick up a route here. An example of how to do a search, I enter the origin. I'll say I'm going from Houston Hobby Airport, which is HOU. Again, 3-letter FAA identifier is what you want. Destination we'll say is Dallas Love Field, and the route type will be low altitude, so I'll put L in there. And then submit the search. It tells us there's a route available to all others, and then a route available to non-turbojet aircraft. So this would be for jets, this would be for non-turbojets, and the route is going to be Houston Airport, then via the Stick 7 departure to Stick intersection, then Cedar Creek VOR to the Yeager 4 arrival into Dallas. And so if I'd like to fly that route and like to fly it like somebody would in the real world, that's the route they're probably going to be given by ATC. That's the preferred route. Sometimes you'll also see two different stars coming in from the same direction, and if you look at the notes on that star, one will be for turbojets only and one will be for non-turbojets. And usually there's a note on the turbojet star as to which star you should use if you're not flying a turbojet. So check the notes carefully and make sure that you are using a star that is available to your type of aircraft. One last thing we want to talk about in regards to both SIDS and stars is altitudes. Both SIDS and stars have published minimum en route altitudes, or MEAs, both for traditional and RNAV procedures. Some of the MEAs can be quite high, particularly on outer transition routes. For example, the MEAs are listed typically above the route, so right above the route from Fort Smith on the Fort Smith transition on the Finger 7 arrival. The MEA on this particular segment is flight level 180, or 18,000 feet, and that goes all the way down to Mammy intersection. Then it lowers to 13,000, and then once you get past Hankin, it lowers down to 5,000. And that's going to be obviously quite high for a Cessna 172. We're not going to be able to get up there. So if the altitude is higher than my aircraft can fly or higher than I want to fly, can I still use that procedure or transition? And why do RNAV procedures even have MEAs? Those are supposed to be for VOR signal reception, right? MEAs guarantee obstacle clearance and signal reception, both nav signal reception and communication signal reception in the real world. So that's why they're published on RNAV routes and procedures. But in Flight Simulator, ATC's radios are pretty awesome. They probably would work at 500 feet off the ground, even in mountainous terrain, and probably even lower than that. So that's not really a factor for us in Flight Simulator. On RNAV procedures, a minimum obstacle clearance altitude, or MOCA, is also often published on the procedure. For example, on the Slant 3 arrival into Dallas, on these segments going in here, we still have MEAs listed here. Those are the numbers without anything beside them. But we also have a number that has an asterisk beside it. That is the minimum obstacle clearance altitude, or the MOCA. Flying at or above the MOCA will keep you at a safe altitude above the ground, so using any altitude at or above this in Flight Sim should work just fine. If you want to fly a transition on a traditional arrival that has a high MEA, but you want to fly a lower altitude using GPS, you should be able to do so. Just check the off-route obstruction clearance altitudes in the areas you'll be flying through and pick an IFR altitude that's at or above the highest of those. For example, one of the routes we looked at was the Fort Smith transition into the Finger 7 arrival, and the pink line here depicts where that would go through on the chart. And our off-route obstruction clearance altitudes are these little brown numbers that are located in each longitude, latitude square on our IFR charts. And picking an altitude at or above these altitudes will keep you clear of all obstacles, and then staying at or above that altitude in Flight Sim should give you radio coverage if you're wanting to use ATC as well. And one last note about altitudes is often you'll see vertical planning information or an altitude restriction on stars, and in some of the RNAV stars you'll even have multiple altitudes to cross or be between certain altitudes. And if you see this sort of thing, for example, at Slant intersection on the Slant 3 arrival, it tells you to expect, if you're a prop, either 6,000 or 7,000 as ATC assigns. And when you're flying in Flight Simulator, if you want to be realistic, you should do this, although sometimes this altitude will be well above what you are flying if you're flying down kind of low if you're flying above the MOCA. So obviously if it's above what you're flying at, then you don't need to adhere to that. But otherwise, if you want to be realistic, it's something that you should plan to adhere to. So let's take a look at a sample IFR flight plan to see how to create an IFR flight plan, load the appropriate portions in the GPS, and how to fly it. This will only cover one scenario out of many possible ways to fly an IFR flight using the GPS, but hopefully it will give you a grasp of the basics. I plan to make a video with a number of different sample IFR flight plans after the video on GPS approaches that will go into more depth on how to create, load, and fly various different types of IFR flight plans in the GPS. For a sample flight, we'll use a route from Ann Arbor Airport near Detroit, Michigan to Cincinnati Municipal Airport or Lunken Field in Cincinnati, Ohio. Our route of flight will be Ann Arbor Airport via the Metro 3 departure, ILE transition, direct to Flag City VOR, Victor 47 to Rosewood, and then the Rosewood transition to the Heedy 4 into Lunken. Our initial magnetic course will be south-southwest bound, so we'll file for 4,000. Normally, we'd take a more direct route, probably from ILE to Rosewood to join the arrival, which would allow us to take advantage of our RNAV capabilities. But this route will give us some practice at loading an en route segment. The Metro 3 departure has us fly an ATC assigned heading for vectors to join the departure route. The Heedy 4 arrival is a single route arrival that terminates at JDAT intersection with instructions to expect radar vectors to an approach at JDAT. All right, so let's talk about how to set up the en route portion before we load up and start loading the GPS. Before you do anything, make sure and check your filters to make sure that nav aids and fix and RNAV position reports are on, so you can see those if you want to use those. And then don't forget to set your aircraft and set your weight and balance. And then after that, you'll need to enter your departure and arrival airport. So we'll do ARB is Ann Arbor, and we'll use runway 24. This doesn't really matter for the GPS. You can still load, if it's a runway dependent departure, you can still load any runway you want. Same thing goes for the arrival airport. So we'll put KLUK, and that's Cincinnati Lunken. And we'll do runway 21 left. And again, that doesn't matter. You can still choose an approach to any runway. You don't have to stick with that one. Before we get to loading up the flight plan, we'll actually go from the VFR to the IFR low altitude airway routes. And what that will let us do is check to see if the departures and arrivals are in there. So we'll take a look at our departures here, and we take a look, and the Metro 3 is in there, so we don't have to build that manually. And then if we look at the arrivals, we can see that the Heedy 4 is in there, so we're good there as well. All right, so to load up the flight plan, we'll go ahead and switch back to the direct GPS route, and we'll load the en route portion manually. Again, since you're taking off out of a tower at airport, you can actually still get an IFR clearance with Flight Sims ATC if you'd like to do that. And so we don't need to put in anything that's in the departure or the arrival. We'll load that all in the GPS. So we just need to put in the en route portion, which is Flag City, Victor 47 to Rosewood VOR. And when you're loading an airway, again, you have to load each point manually, or at a minimum, you have to load the VORs that define the route and any intersection where the airway makes an obvious turn. There's only one intersection on this particular airway, so we'll just load up the VORs in that one intersection. It won't take us that much time. So Flag City is FBC. Don't forget you can use this search function if you're having trouble finding a VOR, an intersection you're looking for. So there's FBC, that's a VOR. Click on that and it'll zoom us into that, and we'll click on Add. And so that's in there now, and then we're looking for, let's see here, It'll be kind intersection, K-I-N-D, and there that is, K-I-N-D-E. So we'll add that, and then our last en route point is going to be the Rosewood VOR. And that is buried underneath a GPS waypoint there, but we'll go ahead and add that in. And then we can take a look at the top here to make sure that everything is added in like we want to. So we have the Ann Arbor Airport, then we have Flag City VOR, Kind Intersection, and Rosewood VOR. So all of our en route stuff is in there now. Don't forget to set up your flight conditions, although if you load the weather, you'll probably have to load it again once you boot up the flight. And then we are ready to fly, and we'll talk about how to load the departure and arrival in the GPS. And one more thing you want to do before you click fly is to click on your nav log and set your altitude. And so just enter your cruise altitude in here. So we're doing 4,000 feet. We'll enter that in there and then click nav log again to get rid of that. And then it's time to go fly. All right, so we're sitting at the end of the runway 24 here in Ann Arbor, and it's a beautiful day, but we actually don't want a beautiful day because we want to fly IFR. So let's talk about how to make some IFR weather. So click on your weather tab here, and then what I usually do is I click on the lowest cloud layer, and I drag the bottom of that cloud layer all the way to the ground, and then increase the coverage to 100%. And now we have a nice overcast out here. And then you can put the tops, wherever you'd like. If you want to be on top, you can put that below your cruise altitude. Just be aware that the thinner you make the overcast, the lighter it's going to be, and then it also actually starts to break up a little bit if you get rid of, bring it down to the base altitude. Also, if you're concerned about getting into the cloud layer too early in your flight, in Flight Simulator, the cloud bases, you're going to have some ground visibility all the way up to about 1,500 feet above the ground. The ceiling doesn't start where the ceiling actually starts, where you've set it in the menu here. So you're going to have visibility up to about 1,500 feet. And then to reduce the visibility for instrument approaches and things, because forward visibility is actually more important, you just want to introduce some rain, and that'll drop the visibility somewhat. What I usually do is I'll do precipitation, and I'll bring it up to about 2 millimeters an hour, and that's enough to do about a mile visibility, which is about what you want to shoot a GPS approach when we get into shooting GPS approaches. So that gives you some nice IFR weather, and that's how to make some IFR weather for flying GPS routes. Let's see, the other thing I was going to mention is if you don't want to get out of the tops, make sure and set your cloud tops, as high, higher than your cruise altitude. Then you'll be in the clouds the entire time. You may need to set it slightly higher than your cruise altitude. Usually I do 1,000 feet or 2,000 feet. If you set it up at 10, you're not going to break out in a GA aircraft more than likely. All right, so let's take a look at how to load the departure in here. So all we do is hit the procedure button and then activate our cursor with the small right knob, and then we use the big knob to scroll down to select departure, hit enter, and then we'll use the small knob to bring up the departure list and use the big knob to scroll down. We want the Metro 3, so there that is, and we'll hit enter. It transfers down to the transition field automatically. Again, roll the cursor to get the list, and we want the ILE transition, so we'll click enter there. And then it's not supposed to be a runway dependent departure, but it loads that up for some reason. So we'll go ahead and load the correct runway in here. Runway 24 is the runway we're using. And then we'll scroll down to the load field there and then hit enter, and that should load the approach into the flight plan. So if we take a look here, it's got the departure, Metro 3, and then it has the fixes that are loaded in the GPS, and we can use the cursor to scroll down. So it has Ann Arbor Airport, then it has a user waypoint that shouldn't be in there, but it's in there. So we'll just ignore that and we'll vector ourselves onto the route. Then it does have the departure, so it's got Detroit VOR, Ants Intersection, and ILE. And if we could scroll down here, we can see the rest of our fixes. Actually, it looks like it got rid of FBC for some reason, but that's okay. We can still edit this. So we'll just highlight the fix we want to push down, which was kind, and we'll put FBC in here, and that will fix that. All right, so there's FBC, so we'll hit enter, and that puts that in there. So we've not got Eiley, FBC, Kind, and Rosewood, and then Lunken Airport. So let's take a look at how to load the arrival now. So the procedure for loading the arrival is much the same. Just hit the procedure button, get your cursor activated, and then scroll down to select arrival. Hit enter, and we want the Heady 4 arrival. So we'll hit enter there, and then we want the Rosewood transition, and then we'll hit enter there, and then it is not runway dependent, so we don't have to choose a runway, and then we'll hit enter. And then again, we can go back to the flight plan here and hit the cursor, and it's got down to Rosewood, and then we see it's got Oris, Heady, and JDAT for the arrival. So it looks like our fixes are loaded in there. And then we can actually pull up our VFR map as well and make sure that everything looks right. So we've got our user waypoint. Again, we're really not going to use that. Then it's got the Detroit VOR over here. And then that flies down to our first fix. Let's see here, Ants intersection, then Eiley, then we take the turn to FBC, then Kind, and then Rosewood for the airway, and then the arrival Oris and Heady and JDAT for the arrival, and then we'll expect vectors at that point, and we'll basically vector ourselves onto the approach. So the flight plan is entirely loaded, and there's just a few other little housekeeping things we need to do before we take off. And like I said, we can actually, since we're at a towered airport, we can dial up the tower and request an IFR clearance. So we'll go ahead and do that and take a listen and see how it compares to a real world clearance. So we bring up our ATC menu and we tune in ground. Actually, we tune in clearance, which is the same frequency. Let's see here, and then we will scroll down to the bottom, and it will say request IFR clearance for instrument flight plan. We can see we also have the option to enable ignoring weather at the airport. If you wanted to take off VFR and use ATC, you can use this, and they will pretend that it's VFR. But we'll request the clearance for the instrument flight plan and see what it sounds like.
Delivery Cessna November 172 Alpha Hotel ready to copy IFR clearance to Lunken.
Cessna November 172 Alpha Hotel is cleared to Lunken Airport as filed. Takeoff runway 24 climb and maintain 6,000 feet. Departure frequency is 118.905, squawk 1645.
And then I'll read that back.
Cessna November 172 Alpha Hotel cleared to Lunken Airport as filed. Takeoff runway 24 climb and maintain 6,000 feet. Departure on 118.905, squawk 1645.
Cessna 2 Alpha Hotel readback is correct. Contact ground on 121.6 when ready to taxi.
And a couple things about that clearance to note is, first of all, even though we filed for 4,000, it did put us up at 6,000. That's a common happening in Flight Simulator. All you need to do is once you get airborne, if you want to use air traffic control, you can actually request a cruise altitude decrease and put in for 2,000 feet lower, and that will give you 4,000. And that's not quite the same clearance that we would get in the real world, but we'll talk about that here in just a minute. It gives you your departure frequency. That doesn't really do anything with the radios, but you'll notice when they give you your squawk code, it will automatically dial the squawk code into the transponder, and it will turn the transponder onto altitude reporting for you. So it's got kind of an automatic feed into the transponder when you do that. Let's take a look at what a clearance in the real world would most likely look like with this type of a flight plan. So a clearance in real life would sound more like this. Cessna 172 Alpha Hotel, you're cleared to Cincinnati Lunken Airport via the Metro 3 departure, Eiley transition, then as filed. On departure, fly runway heading, climb maintain 4,000, and then they give us our squawk code and our frequency. A couple of notable differences there is that they will always read off the departure and the transition, even if you filed it, even if it's not a change to your flight plan. That is just standard operating procedure. The other thing they will tell you is what to expect on departure, although that might come from tower, but they most likely are going to tell you, in this case, fly runway heading. And so what we'll do is once we get airborne, we'll fly runway heading up to about 400 feet, and then we'll turn and start to kind of vector ourselves on the course. And the last few things that we want to take care of right before we take off, we want to make sure that our number one nav display or CDI is coupled to the GPS so that we can use that for navigation. I like to set my heading bug so that it is lined up on what we're going to do, which in this case is runway heading, which is 241 out of Ann Arbor. And then we want to set our altitude for the altitude that we're cleared to as well. One other thing I forgot to mention about the weather is the temperature. You want to set that high enough that you don't get icing down low. You're going to get about 2 degrees Celsius cool off as you climb. So for instance, if I set the temperature to 20 degrees, I know that the freezing level is going to be at about 10,000 or above. So I'm going to set that to a temperature of about 25, and that should prevent any icing. Although the other option there, if you want to do it, is to turn the icing off in the options menu, so you can do that as well. Okay, with all that set, looks like we're ready for takeoff. We'll perform a quick before takeoff checklist, and then we will get in the air. To fly this flight, perform a normal takeoff from runway 24. Climb on runway heading to at least 400 feet above the field. Then you can turn southbound to aim towards the departure course. And once you've got yourself airborne and headed towards the south, we're kind of sort of pointing towards the course. We've got a couple of different options to get on course. With airways, we could go in and we could delete the fix that's behind us, and that would make the fix in front of us active. We can't do that with this route because if we delete fixes behind us, we're going to delete the airport, and the departure is loaded off the airport. So if we do that, it's going to delete the entire departure. So we can't use that technique. So your best bet here is to either steer yourself onto the course, and then once you're on the course, proceed direct or use the GPS direct function to go direct to the next departure fix that's in front of you, or we could just go directly to that fix right now. That would not be an unusual clearance to take off out of a satellite airport, get it headed towards the course, and then hear clearance that says Cessna 172 Alpha Hotel, proceed direct ANTS, resume on navigation, which means basically you can go direct to ANTS, and once you're at ANTS, please resume your flight plan course, including the departure course. So we'll do that. We'll just put in direct ANTS and then resume the departure from there. So we'll hit direct, activate the cursor, and then enter ANTS. So there's ANTS. We'll go ahead and hit enter. It says activate. Yes, we'd like to do that. And then we'll see down here, it will bring us direct ANTS. We can go ahead and hit nav. We've got the couple to the GPS, so that will turn us onto that course. And now we'll proceed direct to ANTS, and we'll fly the rest of the route. All right, so we've reached our cruising altitude of 4,000 feet. We performed a cruise check and leaned out the mixture, and we have it navving on the GPS. So the GPS and the autopilot are going to make all of the turns for us along the entire route here, and we just sit and make sure it does its turns where it needs to. And then at the last fix, when it gets to JDAT, then that's time to put it in heading mode, and then to load and approach, or descend low enough that we can get a visual approach if that's possible. So again, just sit back, and we really don't have to do much else until we get down to that last fix. So one last topic we want to talk about is how to build an arrival or a departure if it is not in the GPS database. So I have a flight down to Austin's Executive Airport, or Bird's Nest, KEDC, in the Austin, Texas area. And I want to fly the Blue 4 arrival coming down from the north. And so when I check the IFR procedures by going to the low altitude airway option there, I can see that If I pull down the arrivals, it has the Potter 1 and it has the Bitter 9, but it does not have the Blue 4. So in order to fly that approach, I have to build it manually. I can also go over here to approaches and check that, and it says automatic. And anytime it says that, that means there are no approaches loaded in the GPS database for that airport. So you can also build the approaches manually. It will also, if it does not have any departures, it will just say direct, and there won't be any, arrivals. It'll say direct, and there won't be any listed there. Same thing for departures out of an airport. If it just says direct, there are no departures uh, in the GPS database for that airport. Fortunately, all the fixes for both arrivals and departures and even approaches are in flight simulators, so we can actually build those manually. So the easiest way to build arrivals or departures or approaches is just to build them fix by fix using the flight planner. And you can do this, you can also do it in the GPS, but it's going to take a lot more time because of all the twisting and turning of individual letters that you have to do, whereas the point and click interface is a lot easier. So if I take a look at the chart for the Blue 4 arrival, I want to fly it from the wind-do transition. So the fixes I'm going to fly and the order that I'm going to fly them in is going to be wind-do, and then blue intersection, and then Susie intersection, and then the arrival terminates at Syntex VOR or CWK. So I go back to the flight planner, and again, we can use the search function to find these fixes. A lot of times, if you don't know where they are, that's the easiest way to find them. So I type in wind-do, there's wind-do, click add, and now I can kind of scroll down and take a look at the fixes as I proceed south. I'm looking for traditional fixes and not RNAV fixes since this is a traditional arrival. So there's blue. I'll add blue, and then our last intersection point is going to be Susie, and there that is. And again, you could use the third search function if you're having trouble finding them. And then the final fix is Syntec VOR, but since I'm landing runway 13 and we're going to come in this direction, that would have me flying over here to Syntex and then back over here to fly in on 13. So that's kind of out of the way. So what I would probably do is just, if I'm going to fly an IFR approach, I'll just load up the approach after getting to Susie. And since the approach is not in here, I'd actually have to load that manually in the flight planner right now. Or again, I could load it on the GPS, but I could just pick out the points that are on the approach and load those in now as well. So that's how you would load an arrival, or you can also do it with departures or again approaches if it's not in the database. You can just build it manually and it will fly that for you if you've got all the right fixes in there. So that finishes up the lesson on using the GNS 530 and 430 for en route IFR operations. In the next lesson, we'll take a look at using the GPS for IFR approaches. If you enjoy the content, please make sure to like and subscribe. Thanks for watching, and we'll see you next time.